What's good, everybody? Welcome back to Algebra 1 with Mr. Peters. In today's video, we're looking at system of equations. So I'm going to break down that topic with two problems, and we're going to focus on how to create systems of equations from a word problem and the methods to solve. So let's get started for today. In the first part of this video, guys, we're focusing on the two methods to solve systems of equations, and that's going to be the elimination and substitution method. But before we get to that part, right, let's talk about equivalent equations. So when we use the elimination process, guys, what we want to do is get rid of and eliminate one complete variable. So if we look at our problem here, let's say I wanted to get rid of y. So to get rid of y, when I combine my two equations, one of these y's has to be negative. So to create an equivalent equation, I'm going to multiply equation 2, the bottom one, by a negative 2 so that we could cancel. So that's the first thing we need to do so we could use the elimination process. So once we rewrite this, we have 2x plus 2y is equal to negative 6. First equation stays the same. Now the second equation, we multiply 3x, y, and 3 by negative 2. So I'm going to have negative 6x minus 2y is equal to negative 6. Now we could combine our variables and our constant. So let's switch colors. So 2x minus 6x gives me negative 4x. Positive 2y minus 2y, it's gone. And this is equal to negative 6 minus 6, which is negative 12. So in the elimination process, we get rid slash eliminate one variable completely and solve for the other. So now I finish this problem off by dividing by 4. X is equal to positive 3. So we figured out the x variable. Now we go back to the original equations and we plug x in. We plug 3 in for x, and then we could solve for the other variable. So let's say I picked the second equation, right? So what we have now is 3 times 3, right? Because that's what x is, plus y is equal to 3. So we have 9 plus y is equal to 3. Once we now start maneuvering this equation around and subtracting 9, we're going to get y is equal to negative 6 as a final answer. And we double check our work. That is correct. So this is the elimination process. Now let's focus and backtrack and let's do the substitution process. So what makes the substitution process complicated, guys, is a two-step process. Number one, we have to solve for a variable. What does that mean? Get the variable by itself on one side. And my advice to you is to look at your equation and pick a variable that does not have a coefficient if possible. So if I'm using substitution, I would want to focus on the second equation and substitute for y. And I'm not substitute, I'm sorry, solve for y. So let's break this down. We have 3x plus y is equal to 3, right? And I'm going to erase this so that we have more space. All right, so we've done that. We're solving for y, so we want y by itself. After I subtract 3x, I'm going to have y is equal to negative 3x plus 3. Now I'm going to put our answer in a box because this is what we're substituting. What do I mean? So we solve for y in the second equation. Now to solve, we're going to substitute into the first equation. So now we have 2 times x plus 2 times y. But remember, y is going to be replaced with this expression. So we replace it, 3x plus 3, and then we finish the equation. Now we successfully substituted and we could simplify. So 2x minus 6x plus 6 is equal to negative 6. I'm going to subtract 6 on both sides to combine my like terms. As we combine these two, we're going to get negative 4x is equal to negative 12. And once we divide by negative 4, we are going to get the same answer of x is equal to positive 3. So when you're dealing with system of equations, guys, these two methods you're going to use over and over and over And if you understand how to make equivalent equations, right, so we could cancel out a variable, right, then it's going to become a much easier process. And with that, let's go on to how to create system of equations from a word problem. In the second part of this video, guys, we're dealing with a word problem. And the word problem reads, Mr. Peters bought 8 tickets to an event and spent $30. He purchased a combination of adult tickets for $5 each and child tickets for $3 each. Which system of equation below will determine the number of child tickets C and the number of adult tickets A? So they gave us the important information, right? So we know that A is equal to the number of adult tickets. And I know it's probably hard to see this, guys, but this is just A, number of adult tickets. And we know C is equal to the number of child tickets. So what do we know about this problem? Let's highlight some important information. And I'm going to tell you guys, if you don't highlight, that is okay. But you have to define what the variables stand for because it makes the process 100 times easier. So it says, okay, Mr. Peters, doesn't matter if it's me or who else, bought 8 tickets. So we know you bought 8 tickets, right? There's a combination of tickets we bought. There's 8 total. We know we spent $30, right? So we bought 8 tickets total. We know we spent $30 for every adult ticket. So every adult ticket is $5 each, and every child ticket is $3 each. So let's start thinking about how this equation should form. We should have one to let us know the combination of tickets. How many tickets did we purchase? 8, right? So when I look at my answer, I could probably eliminate A because we don't see any of these equations equal to 8. So let's just cross out A, right? Now let's start looking a little bit more closely. So all these other equations are going to be a better choice. So we look at B and we notice, right? If he paid $5 for every adult ticket and $3 for every child ticket, is that going to be equal to 8 tickets or equal to the amount of money he spent? It's going to be equal to the amount of money he spent. So we know that this is probably not right either. Now we start looking at the equation and saying, okay, I know that when we add the amount of adult tickets and the amount of child tickets is going to give me 8. So D checks off and C checks off. Now we go to, are the variables with the right number? So we know A, adult tickets are how much? $5. So every adult ticket we have, A, should be multiplied by 5, right? We don't know the amount. So when I start analyzing this much, this equation follows that. 5 tickets for every adult ticket, we do not know the amount. $3 for every child ticket, right? Because that's what the problem told us. And in total, we spend $30. So D would be the answer choice. C is incorrect because they switched our variables. Switched our variables around. They're saying that A, the adult tickets are $3 each, which is incorrect. And they're saying C, the child tickets are $5 each, which is also incorrect. So our final answer choice would be letter choice D. We really hope you found this video helpful, guys. When we're dealing with system of equations, please identify your variables. It's going to make this so much more easier for you. We hope you found this video helpful. Thank you so much for joining Algebra 1 with Mr. Peters today. Smash the like button, subscribe to the channel, and leave comments for future videos you guys would like to see on our channel, or if you guys had questions from today's video.